Hello everyone, my name is Chen Jingzhe. I chose this article called Molecular Interaction of Eastern Monoproteins with Grape Anthocyanins, Enhancing Anthocyanins and Color Stability in Juice as a foundation for my research. I will briefly introduce why grape is a promising source of soluble carbohydrates based on our selected article. First of all, grapes contain rich natural soluble carbohydrates. The juice has 10% glucose and fructose, which perfectly matches the sugar dress model in this study. Based monosaccharides, there are a small amount of oligosaccharides and soluble pectin fiber. All these carbohydrates dissolve easily in water, so we only need small, simple water extraction and centrifugation to collect them with low cost. Secondly, the whole extraction and detection workflow is manual and easy to operate. After closing and clarifying grape juice, we can use ethanol precipitation to separate small sugars and large soluble fiber. We also use XAD7 resin to remove sugar impurities, then HPLC to quantify each carbohydrate accurately. Combined with DSA thermal analysis, we can study how soluble carbohydrate affect and cell science from quantitative and molecular structural aspects. Last but not least, grape has great industrial value. Grape processing techniques are already widely employed in factors. This study proves that Eastern monoprotein can offset the damage that high sugar brings to anthocyanin. Therefore, we can make a natural sweet functional fruit juice without worrying about color funding, which brings meaningful gain for fruit beverage production. Next, let's move on to the extraction process. First is simple preparation. We clean and crush fresh grapes. Add pectinates for clarification. Then filter and centrifuge to get sterilized grape juice full of natural soluble carbohydrates. After preparation, we carry out water extraction. We use deionized water for ultrasonic extraction to dissolve our water-soluble sugar and pectin. Centrifugation removes insoluble residues, and we collect the supernatant as crude soluble carbohydrate extraction. We conduct ethanol precipitation for fractionate different carbohydrates. After concentrating the water extract, high concentration ethanol is added. Large soluble fiber precipitates, while small sugars stay in the supernatant. Centrifugation separates them. For target components, we can obtain three categories: oligosaccharides, soluble pectin fiber, and dominant monosaccharides, glucose and fructose, which are the key material for our sugar stress test. Let's move to HPLC analysis. This test targets formal group anthocyanins. Using 18 reverse phase chromatography to separate them by hydrophobicity before injection resin removes glucose impurities to avoid signal disturbance. The chromatography has 4 clippings, and M-switch is the dominant pigment. Quantification data shows 10% glucose drastically reduces anthocyanins retention to only 40.85%, and for GL monoprotein left retention by 35.8%, proving its protective effect, while 6GL brings no extra benefit as benefits are saturated. Next, let's look at DSA analysis. We use DSA to compare thermal stability of free anthocyanins, monoprotein and their complex. The thermogram shows free anthocyanins denature at only 74.52 temperature, while the complexes denaturation peak rises to 77 temperature. The higher peak temperature means better thermal stability. Soluble glucose weakens isocyanates structure, but monoprotein binds pigments via hydrogen and hydrophobic forces to raise their heat resistance, which explains why MP protects isocyanates during juice thermal processing. Now we move to discussion. First, grape is a promoting soluble carbohydrate ingredients. Its juice contains up to 10% soluble sugars with simple, scalable extraction techniques and natural health-promoting oligosaccharides and packaging. Besides, this study uses non-alcoholic grape juice which matches real commercial drinks, which cite light, heat, acid, and sugar-stress groups, and combine HPLC and DSA to clarify how glucose degrades isocyanates and how monoprotein protects pigments. However, this research still has limitations. It only tests the grapes without sugar concentration gradients, so the results cannot be fully applied to all grape varieties. HPLC and DSC are two vital complementary tools. HPLC quantifies isocyanate loss caused by sugar, while DSC reveals molecular thermal stability changes. Together, they fully explain the interaction between soluble carbohydrates and cyanins. Finally, let's move to the conclusion of this study. Grape is a great raw material rich in soluble carbohydrates and isocyanates, but its natural glucose speeds up pigment degradation during heating and storage. Its monoprotein can bind the isocyanates to raise their thermal stability. Both HPLC and DSA data prove for GL monoprotein effectively increases isocyanate retention and relieves sugar-induced quality loss. Thus, normal protein works as a natural stabilizer for group drinks and more true on other grape varieties, and industrial production can be carried out in future research. Thank you for your listening.